Hello, and welcome to Portland Community College Intro to Building Systems. This lecture will be about passive solar. So, just a reminder that when we talk about conditioned space, we talk about indoor comfort being a collection of four items: the temperature of the air, the humidity in the space, the airflow, and radiant heat. Obviously, when we're talking about passive solar, radiant heat is a big proportion of that. The other thing to keep in mind is that Portland has a temperate slash moderate climate. We'll be looking at climate maps in the upcoming slides. In general, to passively moderate our THAR, our indoor comfort in Portland, the steps that we take are keeping the temperature between the outside and the inside regulated using insulation and shading buildings in our east, west, and south directions. The best way to reduce humidity, besides using a humidifier, either a dehumidifier or humidifier, is if humidity is at a higher level, reduce your activity or increase airflow. For airflow, use prevailing winds, as we looked at in the last lecture, and the stack effect to promote cross ventilation. For radiant heat, again, we go back to the temperature. We want to promote heat in the winter months in our portion of the world, and modify or stop solar radiation from coming in through our windows to the south, the east, and the west, especially in the summer months. This is the first map in our climate zones, and as you saw in the reading, and I'm going to discuss further, where you are in the United States, where you are in the world, what the climate is, has a big impact on how you design a house and how you strategize keeping your conditioned space to an optimal comfort level compared to what's happening out of doors. And there's different strategies based on where you are. This is the climate zones developed by Building America, and there's one that's not shown, and that is the subarctic zone, which is only in Alaska. This one, which is a little more commonly used, is was developed by the U.S. government and is available at energy.gov. As you see, it's divided up into marine, dry, and moist. So moist tends to have high humidity, whereas dry does not, and marine is tempered by the ocean. Oregon has two climate zones. We have marine, which is the yellow in this, and we also have, on the other side of the mountains, we are 5, which is the green color, and that is the name for it is cold. So it's a cold, dry. A cold climate is defined as a region with between 5,400 and 9,000 heating degree days, with 65 degrees Fahrenheit as the basis. And I will describe what those heating degree days are on the next slide. And then a marine climate is defined as a region that meets all of these criteria. A mean temperature, so that's in between the high and the low, of the coldest month between 27 degrees Fahrenheit, which is -3 Celsius, and 65 degrees Fahrenheit, which is 18 degrees Celsius. The warmest month has a mean less than 72 degrees Fahrenheit or 22 degrees Celsius, and at least 4 months with a mean temperature more than 50 degrees Fahrenheit, which is 10 degrees Celsius, and a dry season in the summer. The month with the heaviest precipitation, that's rain, in the cold season has at least 3 times as much precipitation as the month with the least precipitation in the rest of the year. So we have that marine climate in Portland. So I said I was going to describe heating degree days. So this is also a governmental map that is by census zones. So you see the west is Washington, Oregon, and California. The mountain states are together, the southern states in the central, etc. We're focusing on the west because that's where we are. So heating degree day figures start with a base temperature and provide a measure of how much in degrees and for how long in days the outside temperature was below that base temperature. For residential buildings in the U.S., we use the temperature of 65 degrees Fahrenheit. So in the Pacific states, and that is a range, I've got some data about some specific areas in the Pacific, we are required to provide heating compared to the exterior of 3208. Now, so those heating degree days is, again, days, but also temperature difference between 65 degrees Fahrenheit and what the actual temperature of the exterior is. You notice, for example, in the Midwest, they have the highest, in the north central, they have the highest, it's coldest there, and in Texas, it's quite low. In Oregon, some figures that I found, and for some reason I couldn't find Portland, but Eugene, which is very similar, is at 4546. Seattle is at 4908, and Yakima, which is on the other side of the mountains from Seattle, 5967, and Boise, which is in a different zone compared to this, is at 5861. So a lot less heating is required in Southern California than Northern California, but still on this side of the mountains we are fairly temperate, and that's an important thing to keep in mind. So perhaps it goes without saying why we should include passive design strategies. Here are some figures, and it's comparing the U.S., the Pacific, those 3 Pacific states, and California. California has a lot more data available for it as a single state than some others. And if we look at BTU, stands for British Thermal Unit, and that is a measure of energy. A BTU is equal to the amount of energy that is in 1 kitchen match if it burns from the beginning to the end, a little wooden match. The amount that we spend, of course, the more energy we use, the more we spend typically. And if you look at the energy only, which is off to the right, we see that California actually is using less electricity than other of the Pacific states. A big part of that is probably that they have more daylight, as well as needing less electric heating in the winter months. Another way of looking at this, and this has to do with the amount of energy that's used for specific items, and we looked at electricity on the previous slide, that out of 100%, so every region is going to be 100%. It's just that some areas, as you saw in the previous slide, the United States is using a lot more energy than the Pacific states as a group, and California was lower than the Pacific states as a group. However, out of that, as I mentioned, they don't space heat as much, so only 27% of California's energy use is space heating. The 44% of it is appliance, electronics, and lighting. 25% of it is water heating, and only 4% is air conditioning. In the Pacific states, we're sort of similar to what we see in California as opposed to the rest of the United States. If you look at the United States as a whole, there's a lot more space heating happening, and there's also more air conditioning happening. And because of that, the portion that is being used for appliances and for water heating is proportionally lower. But imagine if we can take our space heating number and make it much smaller, as well as our air conditioning, which we saw with passive cooling, we can reduce. Then that means our overall numbers go down, which also would mean that we would be spending more of a percentage on our appliances and water heating. Again, looking at some figures, how things are, what sort of heating and cooling is happening. California and Pacific, let's just look at Pacific this time. We have natural gas in our Pacific states as our main heating source. We have electricity as the next. Other and none is up at the top. So because it includes Southern California, there are places in the bottom of the United States where heat is not required. I will say that, and there is the information at the bottom, 14% of California homes are not heated. I know the state of Florida does not require any heating to be permanently installed in a dwelling. Also, more than 40% of California households don't use air conditioning. The central air conditioning is the biggest chunk, as we see in the Pacific states and in California, with window and wall units being next and none being the greatest. Again, if we passively heat and cool our homes, we can reduce our reliance on electricity and fuels and other things like